Hello and welcome you all. Today in this video we will continue our next real valued function. So our next type is smallest integer function, also known as ceiling function, which is denoted by, as you can see, x. Here x means the smallest integer greater than or equal to x. So to understand this, let us take some real values. Say at x is equal to 4.7, and now write down all the integers greater than 4.7, which are 5, 6, 7 and 8, and in these integers the smallest integer is 5. So smallest integer function 4.7 will give us 5. And now at x is equal to minus 7.2, so here first write down all the integers greater than minus 7.2, and those are minus 7, minus 6, minus 5. So here the smallest integer is minus 7. Therefore at x is equal to minus 7.2, the smallest integer function will give us minus 7. And now at x is equal to 0.75, first we'll write down the integer greater than 0.75, and these are 1, 2, 3 and so on. So here in 1, 2, 3 the smallest integer is 1. Therefore at x is equal to 0.75, the smallest integer function will give us 1. And now we'll draw the graph of smallest integer function. So as you can see on your screen that here I have drawn two axes, x and y. So we know that in the range of 0 to 1, the greatest integer function will always give us 1, and in the range from 1 to 2, the smallest integer function will always give us 2. And now from 0 to minus 1, the smallest integer function will always gives us 0. And then minus 1 to minus 2, it will gives us minus of 1. And then in the range from minus 2 to minus 3, the smallest integer function will gives us minus of 2. So here as you can see that these all are like a steps. So smallest integer function is also known as step function. And now we'll study the domain of the smallest integer function. So as you know that we have put all the real numbers in place of x. So therefore the domain of smallest integer function is all the real number which is equal to r. And now the range of smallest integer function ranges all the set of values of fx. Here range are all the integers. And now we'll study our next topic, which is algebra of functions. So in this we will study various operations, namely addition, subtraction, multiplication, division on real functions. So our first algebra of function is addition of two real function. So here student, let's say a function f from x tends to r and a function g from x tends to r be any two real functions where x is a subset of real numbers. Then we define a function f plus g such that x tends to r by f plus g and in bracket x. So here we will write it as fx plus g of x for x belongs to capital X. And now subtraction of two real function. And similarly, if a function f x tends to r and a function g such that x tends to r be any two real functions where x is a subset of r, then we will define it as f minus g such that x tends to r by f minus g and in bracket x, which can be written as fx minus gx. And now our third operation is multiplication of two real functions. So the product of two real functions such that f from x to r and g from x to r, then a function fg such that x to r defined by fg and in bracket x, which is equal to fx into g of x for x belongs to capital X. And now our last operation, which is quotient, also known as division of two real functions. So here let f and g be two real functions defined by x tends to r where x is a subset of r. Then the quotient of f by g is denoted by f upon g and in bracket x, and this is equal to fx upon gx. Here gx is not equal to 0 because if it is 0 then our function will become not defined. Here x belongs to capital X. And now we'll do some questions which are based on exercise 2.3. So our first question for today is, what is the domain of the real valued function fx, which is equal to 1 upon 3x minus 2. So to find the domain of this function, student, the basic concept is that we will avoid our function to become undefined. So mainly we are focused on the denominator of our function. So here the denominator is 3x minus 2, and when this 3x minus 2 is not equal to 0, so from here we get x is not equal to 2 upon 3. Therefore student, when we put x is equal to 2 upon 3 in our function fx, we get 1 upon 0, which is undefined. So to avoid this, the domain of our function f will be equal to all the real number except 2 upon 3. Here we will not put x is equal to 2 upon 3 because our function will become undefined. And now our second question is find the domain of square root of a square minus x square. Is a minus a comma a, b minus a comma a in closed interval, c 0 comma a in closed interval, and d minus a comma 0. So here let student our function be y, which is equal to square root of a square minus x square. And we know that whatever the terms which are in square root, it will always be greater than equal to 0. So therefore we can write it as a square minus x square is greater than equal to 0. So here we will apply the basic concept of inequality. Yes, I know we'll study it later on, but here you have to understand the basic concept of inequality. Student, listen and watch very carefully. See, whenever we have a term in which the coefficient of x is minus, so here we will always make the coefficient of x positive. So as you can see, student, like 1 minus x is greater than 0. So here the coefficient of x is minus of 1 and we have to make it positive. So here we will take negative sign as common. So in bracket we get x minus 1, which is greater than 0. And now student, we will multiply the expression by negative to make it positive. So when we multiply it by negative, our sign of inequality will get changed. So here the sign is greater than, and now when it is changed, it will become less than. So here we get x minus 1 is less than 0. And now come back to our question. Here a square minus x square is greater than equal to 0 and the coefficient of x square is minus 1. So we have to make it positive. When we take negative sign common, from here we get in bracket x square minus a square, which is greater than equal to 0. And now we'll multiply by negative both sides. So the sign of inequality will get changed. Therefore we get x square minus a square less than equal to 0. Or we can say that x square is less than equal to a square. So from here we get the value of x in the range minus a comma a in closed interval. So our B option is correct. So this is the end of this video.